How about another example of use my integration by parts formula to integrate? Now, very much like my last example, I do think I can easily differentiate this. So here too, I'll make a decision. And I'll pay the consequence of my actions. Now, applying my integration by parts formula, this is indeed u times v minus the integral involving the minus the integral of v du. Do you know what, everybody? I think it might be best if when I differentiate correctly. Would you not agree? I'm missing this. All right, now I've got it. Let's see, minus a plus, I've got this. Now take a peek at what the integration by parts formula is supposed to do for me. It's supposed to allow me to take an integral, which I can't anti-differentiate the expression here. And for an expression involving another integral, that's easier to evaluate. But you have to admit, in this example, this is just as difficult to integrate as this. And so it seems like integration by parts not help me evaluate this integral. But since this is so similar in form to that, maybe if I integrate one more time, I can cycle back. Let me show you. Nothing wrong with what I've done. But applying integration by parts form again. This is what I have up here. I'm just simply rewriting it. Now, giving myself a little bit of room. Let's talk about our new u and our new dv. So apply my integration by parts formula one more time. I'm going to transform this into a math B equation. I'm talking 9th grade elementary algebra. So watch me play with the second application of my integration by parts. So this integral, my u dv, is now going to be u times v minus the integral involved by v du. Now take a peek at how the integral involving cosine of natural log of x is on both sides of the equation. So if I add it to both sides, this will be eliminated, and I get two of them over here. Now, technically speaking, I have eliminated all the integrals on the right-hand side of the equal sign. So I better tell the reader that I have an infinite collection of such integrals. Sorry. I have an infinite collection of such antiderivatives. And maybe even going so far as to isolating this integral by multiplying both sides by 1/2. A different c, but I'll call c and 1/2 c just c. Looks nicer.